Okay, so let's first revise our laws of exponents because we'll be using these to solve algebraic equations, okay? Law number one is the law of multiplications, i.e. when we are multiplying, then you add exponents. So you're multiplying. Only condition we have here is we have to have the same base, x and x. In that case, we would add exponents, okay? A plus B. The second one is the law of division. It's quite the opposite of multiplication, literally. In this case, we are dividing, and when you're dividing, you subtract your exponents. Remember, same bases, okay? Same bases. Law number three is power to a power, which means exactly that. You have a power all raised to another power. Okay, in that case, you multiply the exponents. Do not confuse law 1 and 3. Look at the differences. In law 1, we have two bases, right? They are the same base, but there's two of them. In law number 3, we have two exponents. Do we see that? One base, two exponents, so we multiply. Two bases, then we add. Okay, so far I hope I have lost nobody. Okay, hope I haven't lost anyone. Law number 4 is the distributive law. It means exactly that. When you're distributing, it means you are giving something to everybody. Okay, so the exponent that would be outside your bracket, you will be expected to distribute. So x gets the c and y gets the c. And once you do that, if there were existing exponents, for in this case, there was an a and a b, then we multiply it with the one you just distributed, okay? So it will be a times the c and b times the c, okay? I'm very concerned because a lot of people can't see. So I don't know. I can't help you, Bagan, because some people can see and I don't know, should I? Okay, how about, I'm gonna stop sharing, pause the recording, okay? And then I'll start sharing and see if everybody will see when I do that. Let's do that. There we go. So we've solved our screen issue. And now I'm gonna go back to law number 1 because we have missed everything that I said. So what I said was in law number 1, we are multiplying. Let me do this. For multiplying two of the same bases, then you add your exponents. So we had x and x, so you keep the base. There we kept it, so it's x to the power of a plus a b, okay? Then I said with division, it is the opposite. So if you are dividing two numbers that have the same base, still has to have the same base, then we will subtract the exponents. Let me take out my colors in case you guys want to take screenshots. You will subtract the exponents when you are dividing. There we are, a minus b. Okay, now we're on law number 3, power to a power. So you're going to have x to the power of a, and that will all be raised to another exponent of a b. Okay, in that case, you will multiply the exponents. Check there, we have a times b, right? And then I said, do not confuse it with law number 1. Okay, in law number 1, we had two bases that are the same. And in law number 3, there's only one base. Okay, so then you multiply the exponents. Then here is where I was. Law 4, distributive law. Distribution means everybody gets it. So the c that is outside, you will distribute it to the x and distribute it to the y. So once you distribute it to the x, there was already an exponent there. There was already an exponent there on y. Once you distribute, you multiply the exponent. So this is an extension of law number 3, which is power to a power, right? And then we have two definitions, okay? The first one is any number raised to the power of 0 is equal to 1. Okay, so if I give you any complicated bracket that's messy, or your teacher does it, but then they raise it all to the power of 0, your answer is just a 1. Okay, then the last definition we're going to look at today is negative exponents. So if you have x to the power of negative a, in that case, we take the reciprocal, okay? Reciprocal. So that means if this was the numerator, it will now become a denominator. And if it was a denominator, it will become a numerator. Okay, we don't usually write numbers as 2/1, but 2/1 is the same as 2. In the same way, x to the power of negative a is the same as x to the power of negative a over 1. So it was a numerator, it now becomes a denominator. And when that happens, if you're going to do the reciprocal, remember to change your exponents now to a positive, because that's what we want. Okay. Have I lost anybody so far? Have I lost anyone so far? Are we still good? Thumbs up, thumbs down. Anybody want me to recap one of these laws? Remember, we did these laws, but we will be using them today. Mbali, is it Mbali? Yes, Mbali, hi. Mbali, you can unmute. Okay, Lunati says the last one. Ivile says number 2. Okay, I got you guys. Mbali is not unmuting, so let me start with the last one. Okay, so the last one, Lunati says, if you have a negative exponent, you do the reciprocal. Remember, reciprocal means you swap them around. So if I have 2/3, okay, that is a fraction, right? The reciprocal of that would be 3/2. So it just literally means swap the denominator and the numerator. That's what you did, right? So if we have, for instance, 2 to the power of negative 2, and we want this exponent to be a positive exponent, we will make this 2 to the power of negative 2 1/2 to the power of 2. So now it becomes a positive exponent because we have moved it where it was a numerator. Remember, 2 to the power of negative 2/1 is just the same as 2 to the power of negative 2, okay? Where it was the numerator, it has now gone down and become the denominator, and the 1 was a denominator and it went now and became the numerator. That is what law number, definition 2 says. So if we want positive exponents, in the same way, if I have 1/3 to the power of negative 3. Okay, reciprocal means swap them. So now it will become 3 to the power of 3/1. The only thing I said, if you're going to use the reciprocal, you must remember to change your exponents to a positive. Okay, I'm hoping we now understand. Okay, someone said number 2. Number 2 says, if you're dividing two numbers with the same base, so you have 2 cubed over 2 squared, this is the same as saying 2, because we keep the base that we had. You see, we had a 2 and a 2, so you keep the 2, and you subtract your exponent. So you're going to say 3 minus 2, and that will just give you 2 to the power of 1. That's what law number 2 says. Okay. Law number 4 is a distribution law. Okay. Isn't the positive? Remember, Karabu, we changed the exponents. Okay. We did not change the operation in front. We changed the exponent. So no, it will not become a negative 1. Okay. We change the exponents. The distribution says you have a C on the outside, you distribute. So C, you give it to the X and to the Y, and that's what's happening in the exponents. So there was an A, now there's an A times the C that you just gave it. Okay. For law 2, if there are different bases, we cannot add the exponents or subtract them. Then it's literally just that, numbers with 2 bases. Okay, Bontle? Hello, Bontle?
Ma'am, it's not really a question, but I cannot see the screen.
Okay, try to DM Simone, okay, and get help from her. Okay.
Okay, ma'am.
But all the work that you miss, we are recording this lesson. You'll be able to find the video on the website within 48 hours, okay?
Okay, ma'am.
There we go. Okay, guys. Guys, if you still don't get the laws, we already did this when we did algebraic expressions. That was a section just before this. So if you still really don't get it, we did them very extensively and one by one. So we had a lesson per law. So you must go on the website. You'll be able to find the recordings over there. But today we have to use these to solve equations. Okay, so now let me reiterate. Okay, let me reiterate. The answer is 2 because you said 2 to the power of 3 minus 2. What's 3 minus 2? It's a 1. Okay, that's why the answer is 2. Okay, so now let me reiterate. So in equations, we said this equal sign is literally telling you that the left-hand side is equal to the right-hand side, right? So now we're going to find the numbers that make these statements true. Let's look at A. A says a certain number, which we don't know at this point, so we're calling it y, squared is equal to 36. What squared is equal to 36? What is that certain number? 6. How did you get that, Zekatelo? Do you want to tell us how you got 6? And Cole. Zekatelo's like, nope, not really. Bye. Anyone know how to? Okay, but Botlali says 6 times 6 is 36. That is true. Nsuku? Hello?
Wait. Hi, ma'am.
Hello.
You see, ma'am, so if y squared equals 36, then mathematically speaking, ma'am, you're supposed to say 36 divided by 2, ma'am, which is 6.
Is it divided by 2? 36 divided by 2 is not 6. Which operation are you talking about?
Wait, no, ma'am, thingy. Ma'am, I'm doing what's that thing? Reverse. Yes, ma'am. So the square root, which is 6, ma'am.
There we go. That's beautiful. Thank you for your explanation. Okay, guys, so that's how Nsuku has so lovely told us that you have to square root both sides, right? It is the inverse operation. We learned about inverse operations last lesson. I wasn't there. But we learned about, I know we only learned about addition, subtraction, multiplication, and division. But it works with powers as well. Okay, guys? So these two will cancel each other. If you have a 2 squared, let's talk about the square root of 2 squared, right? This will mean the square root of 4, which is 2. So it goes back to this number over here. So essentially, we can conclude that this square and the square root, which are inverse operations, will cancel each other out. So if you want to get rid of a square, you square root. But what you do on the left, you go and do on the right. Okay. Oral Dean.
Hello, ma'am.
Hello.
Ma'am, I wanted to ask you, how do you know which rule you're using for each sum?
You must just know the laws, okay?
Okay, ma'am.
You must just know the laws. Remember I said if you weren't in the lessons when we did all the individual laws, then the videos are available on the website, okay?
Okay.
There we go. Okay, Angel, you need to raise your hand and tell me exactly where you don't understand. You need to raise your hand, darling, so we can talk about it. Everyone else, how are we feeling about the first one? Remember, you are interpreting the equation, okay? If something squared is equal to 36, then that something has to be 6. There is no other number squared that will equal 36. Angel. Hi, Angel.
Hi, ma'am.
Where did I lose you?
Ma'am, I do not understand how we got the answer 6.
Okay, do you understand this part? Do you understand that the square and square root are inverses or opposites of each other?
Yes, ma'am.
So that's what we did, okay? So if we have y squared, we want to get rid of the squared, right? We want y to be on its own, right?
Mhm.
So if we want to get rid of the square root, the square, excuse me, we're going to have to square root because as you said, it is the inverse operation. Do we see? Angel,
Yes, ma'am, I hear you.
do you understand now?
Yes, ma'am.
There we go. Okay, guys, I'm glad I'm still with you at this moment. Let's do number B. Okay, so number B says 3 to the power of x is equal to 3 to the power of 3. What is x? So 3 to the power of something is equal to 3 to the power of 3. What does that something have to be? How?
Ma'am, it's what? It's 2.
How did you get 2?
Ma'am, when you x is equals to 1, so 3 over x is technically 3 over 1 or 2.
But we're not using the laws here, Mohau. Do you see what this says? It says there's a number. If you make it an exponent of 3, it will be the same as 3 to the power of 3. So what does x have to be?
3.
Exactly. Do you see? You don't even have to have a long working out here. X is equal to 3. Check here, guys.
Yeah.
We have the same basis. Thank you, Mohau. Thank you
You're
very
welcome,
much
ma'am.
for helping me. We have the same bases here, a 3 and a 3, right? So we have equal bases, and we're telling you that the left-hand side is equal to the right-hand side. So if 3 to the power of something, do you know what something is the same as 3 to the power of 3, then that something has to be 3. Do we get it, guys? We haven't tapped into the laws yet. Don't be tense. Now we're just trying to make logic of algebraic equations that involve exponents. Okay. Now we are tapping into the laws in number C. Who has an idea of how we're going to work with number C? Now we could use a certain law. How did you get 4, Akunzi? Karaba has an answer for us, but I want Karaba to tell us how. There we go. Musha has told us how we're going to do it. We are using law number 1. Check here, guys. And those dots over here is not a comma, it is a multiply. So we're multiplying the same bases, right? So law number 1 said, in that case, we have to add our exponents. So we're on number C. So it's going to be 2. So you keep the base. It's going to be 2 to the power of x plus 3 equals 2 to the power of 7. Now what? Now what? Yes, beautiful, guys. It is law number 1. Kuputsa also has the answer, but Kuputsa has to tell us how they got the answer. Now what, guys? Check what we did in B. We have 2 sides with the same bases. What can we do to the exponents? What can we do to the exponents? We have a 2 on the left and a 2 on the right. What can we do with the bases now? Yes, Eddie.
We can add them, ma'am.
Add them. What are we adding?
No, sorry.
Check what we did in B, guys. We had the same bases, so we equated the exponents, didn't we? If 2 to the power of something plus 3 is the same as 2 to the power of 7, then that something plus 3 has to equal 7. Do we understand, guys?
Ma'am,
Mm-hmm.
is it 2 to the power of 4?
Well, x is 4. Do you see that? Do we see that, guys? Thank you, Mpo. Mpo has so nicely written it for us. But Tabile, raise your hand so that you can tell me where I lost you. So if you have the same bases on 2 sides, look at here at number B, right? Same base, same base. So exponents have to be equal. Remember, this is an equation. It's telling you that this side is equal to that side. So if 3 to the power of something is equal to 3 to the power of 3, then that something has to be 3. In the same way with number C, 2 to the power of x plus 3 is equal to 2 to the power of 7. That means x plus 3 has to equal 7. So then how much is x, guys? If x plus 3 is 7, then x is how much? 4. Thank you. How? We're using inverse operations. So you're going to say x equals 7 minus 3, which is equal to 4. Sponga, remember, don't spam the chat. Do not spam the chat. Michael, raise your hand and tell me where I've lost you. Welcome, Tando. Welcome, welcome. Raise your hand, guys. There we go. Hi, Michael. May I unmute, Michael?
Unmute.
Hello.
Hi.
Hello. Where did I lose you?
I don't understand how to do the equations due to the audio sound.
Is it glitching?
No, like I couldn't hear just now.
Oh, so you missed the first half of it. Okay, let me explain. Okay. So look at B. Can you see B?
Yes.
So B says 3 to the power of x. We use x because we don't know what's there. So 3 to the power of something, a number, is the same as 3 to the power of 3. You see that?
Yeah. Yes.
That means that something has to equal 3. Do you understand?
Yes.
Because if the bases are the same, we have a 3 on this side, we have a 3 on that side, then the exponents have to be the same. You get it?
Yes.
So if we go from B, let's look at C now. So we applied the first law of exponents. It says when you are multiplying two numbers that have the same base, we have the same base, a 2 and a 2. When you're multiplying two numbers with the same base, we add the exponents. That's what we did in step 1. Are you still with me?
Yes.
Beautiful. And then after adding them, I go back to my rule. If the bases are the same, then the exponents have to be the
Same.
same. So do you see why I made them equal?
Yes.
Yes. And then we solved for x using inverse operations. If it was a plus on the left, it will be a minus on the right. That's how we got to a final answer of x equals 4. Do you see now?
Yes. I understand now.
Beautiful. Then I'm happy. Okay, guys. I see people are giving me answers for C, D. Is it D? Because we just did C. So I'm not sure. Okay, people say D is 11. Let's check. Let's check, okay? So now we're doing the division law. If you are dividing numbers with the same base, tell me what are we supposed to do with the exponents? Tell me what to do with the exponents. They have the same base. So what do we do with the exponents? Nsuku? Excuse me. We are dividing, guys. Remember, we're not multiplying, we're dividing. Yes, Nsuku?
Hi, ma'am.
Hello.
If we do, ma'am,
Oh, you're cutting. You are glitching. So we can't hear you. Oh, so we put your answer in the chat. I was really,
wait, ma'am.
really looking forward to hear. Mm-hmm.
Yes, ma'am.
There we go.
We
Couldn't
are,
hear you.
if we are doing, yes, ma'am. If we're doing division with exponents, then we have to subtract.
Beautiful. So it's going to be 2 to the power of x minus 5,
5.
right?
Yes, ma'am.
Beautiful. Now, guys, I need you to tell me what's happening with that 16. Our whole sum relies on the fact that we have to have the same base. Is it possible for us to make 16 2 to the power of something? The only way we can make exponents the same is if the bases are the same. So how do we get 16 to equal 2 to the power of something? Who knows?
Ma'am, we thingy, ma'am. So you have to say, if you have to, so 16 divided by 2 is wait, no, ma'am. I'm thinking, so if 4 times 4 is 16, ma'am, then that means that 2 to the power of 4 is equal to 16, ma'am.
Let's see. Let's test what Nsuku is saying. Thank you, Nsuku, for helping me. So Nsuku is saying 2 to the power of 4 will be the same as 16. 2 times 2 is 4, times 2 is 8, times 2 is 16, and that is correct. So we will change 16 to be 2 to the power of 4 because we want the same bases. Remind me again, if we have the same bases, then the exponents have to be, tell me in the chat. The bases are the same, the exponents have to be what? The bases are the same. Thank you, Oral Dean. The exponents have to be the same. We are not dividing. Concentrate, guys. We are now here. Look. Now we have gotten these two sides to have the same base, 2 and a 2. So the bases are the same. Then we can make the exponents the same, equals 4. Then again, we use inverse operations. Therefore, x is equal to 4 plus 5. Therefore, x is 9. We are getting better at this. Getting better at this. We have one more to do. We have another one to do. Anyone have ideas on how to do number E? Beautiful, guys. You guys are doing beautiful. Where do you think we should start with number E? Yes, Karabo, x equals 9. Rotabile? Hello?
Hello, ma'am.
Hello. Do you have an idea of where to start with E?
No, ma'am, I'm not at the question.
Oh, okay. Let's hear your question.
Ma'am, I don't understand how we got, how you solved the.
Okay, remember, okay, let's start over here. The second law of exponents says what? If you have the same base, which we do, we have a 2 and a 2, right? So we have the same base, and you are dividing. What do you do to the exponents? Okay, Rotabile is muted again. There we go. Rotabile? Okay, it says you subtract the exponents, okay? Which is what we did over here, x minus 5. Okay, then I said we need to change this 16 to a number that has the same base as your left. We had a base of 2 on the left. So we wanted a base of 2 on the right. Then Nsuku helped us and told us that 16 is the same as 2 to the power of 4, because 2 times 2 times 2 times 2 is 60. So we have solved that problem. 2 to the power of x minus 5 is the same as 2 to the power of 4. Now I said if the bases are the same, the exponents have to be the same. So that's what we did in, I almost said volgende, sorry, in the next step. Okay, so then we said x minus 5 equals 4. Now we had to use inverse operations, which is what you guys did on Tuesday. I wasn't here, but I trust my lovely colleague Coco. Okay, you take the 5 over to the other side. If it was a negative, it becomes a positive. So that's how we ended up with 4 plus 5, which is just 9. I hope you feel better. Okay, I saw another request to repeat D, and I just did. So I hope we're feeling better now. Okay, anyone with an idea? People have been looking at E. Has anyone thought about where we're going to start with E? Anybody? You're welcome. Anyone? Ideas for E? Thank you. Mpo says, let us start by getting rid of this 3. Because how will you have the same base if you still have a 3 that's just chilling there, right? So if we had 2 to the x plus 3 equals 131. Mpo says, get rid of this 3, take it over to the other side. If you do that, let's see if Eddie wants to help me do this one. Yes, Eddie.
You would take it over and it would become 131 minus 3.
Thank you. So it'll be 131 minus 3. So 2 to the power of x is how much?
128, ma'am.
128. Thank you. Now what do we want to do?
Now we want to get rid of the 2.
We want the base of 2. Remember, we're not multiplying by 2. Now the x is the exponent. So if the x is the exponent, we want a base of 2 on both sides so we can make the exponents equal. So if we have a base of 2 the side, we want a base of 2 on the right. Who knows? 128 is the same as 2 to the power of what? Who knows? I see Mpo has told us something there. Let's check. Mpo says 2 to the power of 6. 1, 2, 3, 4, 5, 6. Almost there, but not quite. 2 to the power of 6 is 64. Yes, Eddie?
It's 2 to the power of 7.
Thank you very much. So 128 is the same as 2 to the power of 7. Guys, if you're doing this with your calculator, then you can go on your calculator and press 128. Press equals, and it's going to say 128 again. Then press shift and press fact. That's the button with the commas and the dots and the 2 commas and the blah, blah, blah. Okay, and it's going to tell you that 128 is the same as 2 to the power of 7. So then we're going to have 2 to the power of x is equal to 2 to the power of 7. We have achieved same bases. What happens once we've achieved the same bases? We have a 2, we have a 2. What happens once we achieve the same bases? Let me know in the chat. Nope. Yes, Mpo. Anyone else? If the bases are the same, then the exponents are what? Same base. Thank you, Oyama. 80 says equal as well. Spona says same. There we go. So if the bases are the same, therefore, x will be equal to 7. Whew, that was a lot of work. I'm gonna zoom out, allow you guys to screenshot while I take any questions, and then we're gonna go into our brain break. Zoom out a little bit more. There we go. So I'm allowing you guys to screenshot. If you have a question, now is the time to raise your hand. Not a single question. I am worried. Oyama says easy. I love it. So let me give you a few more seconds to take screenshots. Oratile.
Hi, ma'am.
Hello.
So ma'am, the question I have is not regards to this, ma'am. So like, ma'am, since like last week, ma'am, I had a load shedding problem, ma'am. So ma'am, for for the topic that we did, ma'am, factorization, ma'am, of fractions, ma'am, because we just started it today, ma'am. So like, if possible, ma'am, can you please help me, ma'am?
Okay, we'll see if we have enough time at the end of the lesson. Okay, just remind me at the end of the lesson.
Okay, thank you, ma'am.
You're welcome. Okay, someone said, please repeat E. Step 1, we got rid of the 3, okay? Using inverse operation. We were adding, so we got rid of it by subtracting. So if you were adding, you get rid of it by subtracting. Cool. So then 131 minus 3 is 128. Then I said we want the same bases. So we have a 2, we wanted 2 on the right. So you have to change 128 to a 2 to the power of something. So I said, if you don't know how to do that, go on your calculator and do these steps. Press 128, press equals, get the button that says equals. I know it's gonna pop up 128 again. Press shift at the top of your calculator and then press fact. That's the one with the commas and the full stops and the circles. And that's gonna tell you that 128 is the same as 2 to the power of 7. So now we have 2's, bases of 2's on both sides. If the bases are equal, the exponents have to be equal. Okay. Wonderful. I'm glad you guys are enjoying this and doing well. Let's do our brain break. Then we'll do maybe 1 or 2 more before you guys go off and do your quiz. Okay, brain break. That is our shape on the left. Which one is the top view? Let's see what you guys have to say. That's beautiful, Mao. I like it when you guys are understanding. Which one is the top view? Should I zoom in a little bit more? Let's see. Here we go. Which one is the top view? Let's see. Who has their hand up? Mulemo. Yes, Mulemo.
Hi, ma'am.
Hello.
The top view is C.
How did you know that, Mulemo?
Ma'am, because the green, that color green is on the right side, and as you can see, the pink one is on the left.
Oh, so that's how you found it. Okay, that's interesting. Yes. I see everyone in the chat is saying C. I wonder how we all knew this. I wonder if we all seen this before. I wonder. Let's check if it's C, guys. Okay. So Maliama says this green, this one that I'm marking, is on the left. Noted. So the one on top has to be yellow, correct? On the right has to be green, correct? And the bottom has to be red, correct? Okay. And then next to the green, the first one connected up there is another green. That is correct. On the side is a yellow, correct. Blue, yep. And red, yep. So indeed, it is C. You guys are either way too good at this or you've seen this before, but it's okay. I forgive you guys. I forgive you guys. What is the number under the car? Sure, I'm gonna believe you guys. What's the number below the car? Krab says 90. Mohau says 90. Zoom user says 90. Nsuku, let's see what Nsuku has to say. Hello.
Ma'am, it's 87, ma'am.
How did you know that, Nsuku?
Because I flipped my phone over, ma'am.
Smart. Did you know to do this? Have you seen this before?
No, ma'am, it's actually my first time, but I'm just smart like that.
Yes, you are. That's why you're in my class. Hey, I'm kidding. Okay, guys. So Nsuku has told us that this is 87. Flip your phones or laptops over, guys. I can't do it because then you see me upside down. It'll be very strange. But if you flip your laptop over, you'll see that this first one is actually 86. That's 88, 89, 90, and 91. So then that means this one has to be 87. Beautifully done. I know. How do you guys think of these things? Like, I'm just like, wow, what a difficult, what a beautiful. Yes, Eddie.
Ma'am, can you just quickly erase what ma'am wrote there? I just want to take a screenshot of it.
Okay. Let me do that. There we go. There we go. There we go. We good? I hope so. Okay, guys, that's all I have for brain breaks. I don't know you guys are so smart. It was going to take you literally 2 seconds. But, of course, I'm going to spice our lives up a little bit more. Let's see what's going on over here. Let's talk about number 8. Reminder of the laws. So if you have 2 bases, we have 2 bases in this case. We have 4 and we have a x. What do we do with the exponent that is outside? It's in the name of the law. The name of the law is gonna tell you. Oh, it's Michaela. Sorry, Michaela. There it goes. Bunga got it. We're going to distribute. So let me number that. 8. So 4 is going to get a 2, well, squared, exponent of 2, and x is going to get an exponent of 2. And this is going to be equal to 64. So 4 squared is 16, x squared equals 64. Wonderful. Eddie, do you have the next step for us? Yes, Eddie?
Okay. So we're doing B now.
No, we still have to solve for A. We want to know what x is on A. What can we get rid of next, do you think?
Ma'am, we can say okay. Can ma'am just choose someone else? I forgot what I wanted to say.
No problem. Is there anybody who knows what we can do next? There are 2 operations that we can get rid of. The 16. Thank you, Anati. Anati Zekatelo's hand is up. Yes, Zekatelo. What are we doing next?
Hello, ma'am.
Hello.
I think we're gonna put the square root sign between the for both of them.
What do you think we can do? We can actually do the square root now that I think about it. Let's do the square root, Zekatelo. What am I gonna have on the left-hand side if I square root it?
You're gonna have 4x.
4x equals how much?
8.
8. Beautiful. Now we still have a 4 to get rid of, Zekatelo. How do we get rid of that 4?
Divide by 4, both sides.
Divide by 4. Zekatelo is making my day. Therefore, x is equal to
2.
Thank you very much. Zekatelo, you are super fun.
Thank you, ma'am.
Okay, guys, Zekatelo decided to start with square rooting. Okay, but I did see someone say 16 first, so it was possible over here. Let's see 16x squared equals 64 to divide by 16 first. So then x squared will be equal to 4. You square root both sides and you still get x equals 2. We are starting to think critically and I am here for it. I'm loving it. Guys, I'm loving it. Okay, let us do, okay, number B is going to be too easy now that you know my trick. Let's do C quickly and then we can go off and do our quiz. Number C, what's happening there by number C? Okay, let me separate these solutions because otherwise someone's going to get confused. So this was solution 1. And this is solution 2. Now, oh, we're doing number C. Pretend that was a straight line, guys. Pretend that was a straight line. Now we're doing number C. Anyone know? The nice thing is all the bases are the same. So really, guys, actually gave it away. Check it. We have the 3. We have the 3. We have the 3. What do we do with those 3's? What's happening there? We are timesing and dividing. So what do you guys think we can do with number C? Anyone? Nope. Okay. Oyama. There we go. Oyama saves the day. Yes, Oyama. Oh, you muted mistake by accident. Yes, Oyama. There we go. Nope. There we go. Nope. Muted again.
Hi, ma'am.
There we go. Hi, Oyama.
I think we're gonna open by brackets binomial by binomial.
No, remember, this is not a binomial. This is monomial. There are no pluses and minuses. Do you see? Okay, Oyama vanished again. Oh, this is a monomial, guys. Someone says just subtract the exponents. I am loving your thinking. Masi, I am loving your thinking. Guys, we're not dividing the bases. Check, we have the same base, okay? If the question was just the numerator, what would you do? Because it's 2 bases that are the same. Then what would you do to the exponents? If the numerator was the question, just the numerator, what would you do to the exponents? You would add them, right? You would add them. So you would say, this is the same as 3 to the power of x plus 2, then it's 3, just 3, then it's equal to 3 to the power of 5. Okay, we're done with one part of it, okay? Now, we are dividing. Remind me again, guys, if there is no exponent, what is the exponent? If there is no exponent, what is the exponent? 1. Segatelo says 1. So now when you divide, what do we do to the exponent? We're dividing. Thank you. So we're going to say 3 to the power of what we had at the top, 3 plus 2, minus the exponent at the bottom. We said if there's nothing there, there is a 1. And this will be equal to 3 to the power of 5. Now it looks like what we have been doing this whole time, right? We have managed to get the same bases. And once again, same base means what about the exponent? Same base means what? Same base. Yo, keep saying base. Same base means no. What have we been doing the whole lesson? We're not multiplying or dividing, guys. We have 2 bases that are the same on different sides. If the bases are the same, then the exponents are what? Thank you. So x plus 2 minus 1 is equal to 5. Therefore, x is 5 minus 2 plus 1. So x is 5 minus 2 is 3 plus 1 is 4. Whew. Wow. Okay, you guys can go off and do your quiz. The person who wanted help, we have run out of time. Can you see that I'm going in the next class? So unfortunately, I cannot help you. Please watch the lesson recordings.